For soft flat construction, which is also called theatrical style flats, we will need a supply of corner blocks. My drawing shows a modified construction method using only corner blocks as the joinery method, but you may also use the traditional method, which uses keystones for toggle joinery and half straps for cross bracing joinery. The standard corner block size is 8 inches on either side of the 90-degree right angle corner. You can cut 8-inch squares and then cut them in half on the diagonal, but I'll be demonstrating a method using the radial arm saw and a corner block jig that is much more efficient. If we draw a corner block on Vectorworks, we can quickly determine that the height of our right triangle is approximately 5 5/8 inches. That is the measurement we need to rip our 1/4-inch plywood in order to use the corner block jig with the radial arm saw. If you don't have Vectorworks handy, you can do the math with either the Pythagorean theorem or with our formula for the right angle isosceles triangle. Using the Pythagorean theorem, we remember that the Pythagorean theorem is a squared plus b squared equals c squared. Our formula for x then becomes x squared plus x squared equals 8 squared. 8 times 8 is 64. Add the x squared plus x squared to get a formula of 2x squared equals 64. Divide both sides by 2 to get x squared equals 64 divided by 2, which is 32. X then equals the square root of 32, which comes to 5.6559 inches. Using the right angle isosceles triangle formula, we know that the two same sides of our triangle are equal and that the hypotenuse of the triangle is x times the square root of 2. The square root of 2 is typically rounded down to 1.41. In our formula, x times the square root of 2 equals 8. We divide out the square root of 2 to get 8 divided by the square root of 2, which becomes 8 divided by 1.41. And our final answer is x equals 5.6738 inches. We still need to convert our decimal inches to a fractional inch, and in this case, we will convert to 1/8 of an inch. Our formula for conversion is two fractions and cross multiplying and dividing. We fill in our formula with our fraction of inches, 0.6559 over 1, and we're going to convert that to y over 1/8 of an inch. We cross multiply and then divide by the original denominator to get our answer for y. 0.6559 times 8 divided by 1 equals our answer, which is y for how many 1/8 of an inch. Our answer is 5.2472. We round that down to 5, and we get an answer of 5/8 of an inch. In our second example for the isosceles right triangle formula, we came up with an answer of 0.6738. We put 0.6738 of an inch over 1 inch equals y over 8. We cross multiply and divide by the original denominator to get our answer for y. 0.6738 times 8 divided by 1 equals our answer for y for how many 1/8 of an inch. Our answer is 5.3904. We round that down to 5 and get an answer of 5/8 of an inch, and x is therefore 5 5/8 of an inch. My goal is to have an 8-inch by 8-inch triangle, an 8-inch by 8-inch 90-degree isosceles triangle. Isosceles means this side and that side are both the same, and right triangle means this is a 90-degree angle. I've made 3 boards here, 3 different sizes. So we can cut a board to 8 inches, but if we do this, our triangles are going to be gigantic. So I don't want to cut my board to 8 inches. If I do the math, my board is going to come out to 5 5/8 of an inch. And that's going to put me into pretty darn close to an 8-inch triangle. If I don't want to get that precise, a 6-inch board is just fine. And I wanted to cut a strip of 6-inch boards, and I wanted to cut the rest of them at that 5 5/8 so that I had a full range of options to show you. And the 8-inch width is kind of the minimum. The 6-inch board is going to be slightly more than 8 inches, and that's okay, but it's not going to be gigantic. This is our corner block jig. It's a real simple thing. It's just a piece of plywood and a board set at 45 degrees and another board here that kind of limits the travel here for up to an 8-inch strip of material. And this makes cutting the corner blocks so much easier. If you cut your plywood all into squares and then take your squares to the bandsaw or the miter saw or the table saw or some other saw to cut them into 45s, you're going to have a whole lot more work than if you're able to set up a jig with the radial arm saw. So the first thing you do is you line this up. Make sure there's no garbage here because we want to be square to the fence. Maybe some chips or something. I'm going to pull my saw forward and I'm just going to slide up to right next to it. There's a big groove here. The jig has been used quite a few times and it's still functioning just fine. It'll be probably time to make a new jig soon. I had to make some adjustments because my jig has been used and abused and I was getting that little corner missing. So I made an adjustment and now I've got a proper corner on the rest of them. It's still going to be fine. It's still going to be usable, but I want to be a little bit more precise. So once I get that set up, I can screw this into the deck. There may be some screw holes already. Two is probably enough. It's not going to move. But it looks like we might have done 3 or 4 the last time. I'm not going to put a screw in here because I don't want it running through there. Oh, there's a couple of spots here. So I'll just do 4. 4 is plenty. So this was set up to handle an 8-inch board. An 8-inch board is going to make a triangle that's much bigger than 8 inches. So the first one I do, I bring it all the way to the front, and this is going to be a cutoff. The first piece on every strip is just going to be extra, so it's going to be extra small. I'll save it for some special purpose, but there we go. Wait for the saw to stop. This is just extra. It's not going to be needed for our normal corner blocks, but as a small corner block, it will come in handy, so I'm not going to throw it away. So now all I'm going to do is I'm going to flip this over 180 degrees and line it up to here and line it up to there. And I've cut a corner block that's the right size. It's 8 inches along here, 8 inches along here, and whatever that distance is. And I can cut a bunch of these in rapid succession. one strip of plywood, made that many corner blocks, and I did it real quickly. I also had 2 extra small corner block cutoffs, and this one with a little corner missing. So these are surplus. I'll use them where I need to chop off a corner or something in a special application, but we'll save those as well. We've cut our 8-inch corner blocks. The smaller square, the smaller triangle is the 8-inch corner block made from the 5 5/8 inch wide strip. This one is the slightly more than 8 inches made from the 6-inch wide strip. And over here we have the 8-inch wide strip, which is pretty darn close to our 5 5/8 inch. Pretty darn close. But we're going to talk about this when we're laying this out. The reason why we cut these into the 5 5/8 inch strips and used our jig has to do with the way the grain ends up being oriented and the advantages of that. And we're going to talk about that when we lay out the flat. As you see with the squares, if we cut squares and we cut them diagonally, our grain is going to be oriented a specific way, so that's going to require us to put the corner block on a certain way. So there's left and right corner blocks when you cut it like this. When you cut it this way, all the corner blocks are lefts and rights. Until we get into talking about chamfering the edges, you can chamfer the edges on the belt sander or on the disc sander. If my blade on my radial arm saw wasn't dull, I shouldn't be getting all of these splinters. So I do have a lot of splinters to clean up on these. And I do want to clean that up with a little light sanding before hands get handling this completed flat. But corner blocks. When we're making soft flats with our corner blocks and our keystones and our half straps, we can make them a little bit safer for backstage, for stagehands while they're setting up the stage, and for performers while they're performing backstage. And that is to put a little chamfer in the edge, a little 45-degree bevel all the way around the outside. I'll do the half straps first because they're the smallest. Just want to keep your fingers away at all times. I don't want my fingers anywhere near the blade. And it's just a 45. I'm not trying to round it. I'm just going to put it at a 45 and a real light pass. 45 and a real light pass. keystones with a nice bevel. That will keep the hands and the fingers of performers and costumes of performers and hands and fingers of stagehands free from splinters. Same with the half strap. And the same with my modified corner blocks, the ones with the grain going on the diagonal. With the grain going on the diagonal, there is no left and right, so you're just good to go by chamfering one edge. We don't do the other side. This is the side that's attached to the flat. But if you make your corner blocks with the grain going vertically or horizontally, you have to make left and right. One's going grain one way and one's going grain the other way, because you need to have your blocks in both positions. So you need 50% like this and 50% like that.